Hello everybody and welcome back. Root Beer here with question number 20 on the grade 7 2004 Gauss paper. Okay? Hopefully you're as eager as I am to try this question. Hopefully you've already tried this question. So that's the best thing to do. Practice on your own, then come watch these videos or look up Waterloo's solutions. Okay, so question 20. The area of square ABCD, which is the one we have shown here, is 64. And AX is equal to BW is equal to CZ is equal to DY, and all of these lengths are 2. What is the area of square WXYZ? This smaller square made by connecting these points that are pushed a little further in on the sides. Okay. So we have 58, 52, 48, 40, and 36. Alright, well they're all less than 64, so they're all certainly possible. But we want to ask, well, how do we get an answer here? Okay? And I think I can think of 2 ways to work out the answer off the top of my head, and then a couple of them are variations that are just sort of unnecessarily fancy. But let's do as we always do and redraw the picture. I think for the first little bit we'll have to do some diagram chasing, figure out some of the other lengths here. Okay. Oh, that's not gonna go well. This to this to this this to this. Okay, not a super exact diagram, but it's working. We want W here, we want B here, and I think I want W, X, Y, Z. Okay. So first thing I know, we got 2's here. Alright. So we got 2's there. What else can we do? Well, it's a square. So whatever this side length is, maybe we'll call it S, we know that S squared has got to be 64. We also know that these other lengths are S minus 2. So if I just knew what S was, I'd be all set. Well, we can grab our calculator if we need to, but hopefully you know that the square root of 64 is 8. That's sort of a very small square number, 64, that you should know the square root of. Okay, I usually say, know your squares up to maybe 20 squared. 30 squared is good too. But I mean, for the grade 7 Gauss, up to 20 is definitely enough. Maybe for later contests. Maybe if you were going into the Fermat, I'd say know your squares up to about 32 squared, 33 squared. Because those are the ones that are just over 1,000. Okay, so the side lengths of the big square ABCD must be 8. All right, the sides of ABCD are 8. So we can work out AW and BZ and CY and DX. All of these must be 8 minus 2. That's 6. So we've got 6's here. So we can get rid of this S minus 2. Put 6's in here. Okay. And then we sort of have 2 options as I see it. We can note we've got right angles, because it's a square. We got right angles there. And so what I can see is, so I'll lay out my 2 possibilities. One, we can work out this side length, the side length of our square. We can let T equal the side of WXYZ. So to answer our question, what's the area of WXYZ? We just need T squared. Okay? And we can use the Pythagorean triangle, 2, 6t, 2, 6t, to work out that t squared is 2 squared plus 6 squared. And hey, that's 4 plus 36. That's 40. I don't actually need to know what t is, because what I wanted was t squared. So our answer is 40. And I think that was one of the possible answers. Yeah, it was D. So that's one way to do it if you notice sort of the Pythagorean triangle connection. But it's not the only way to do it. Okay. Another thing you could do, especially if you're not versed in Pythagoras' theorem, which from what I remember, I think we went over that when I was going through school in about grade 7 or 8. So it might be brand new to you. This might be the very first time you even heard of it with me saying it. Okay, so there are other ways to do this question, some that you might be a little more comfortable with. And I'm going to go through one of those now. Okay. I always like it when there are multiple ways to tackle a question. Okay? But if you don't know about Pythagoras' theorem, I highly suggest you look it up. Okay? That's something to go and Google or whatever you want to do. Look it up, ask your teacher. Very important, especially because it comes up everywhere on math contests. Okay. So another way we can do that, is we can realize that our smaller square is really just the area of our big square, ABCD, minus all of these right-angled triangles. And they're all the same right-angled triangle. So a minus 4 of these guys, which are 6 and a 2. So the 6 and the 2, that's the base and the height. That's enough information to work out the area of these triangles. And we know the area of the big square. It's 64. So 64 minus 4 times the area of these triangles. Area of the triangle formula is definitely something you know. So we subtract those off. We subtract the triangles off. We sort of cut them away. We remove them. And we're left with the area of WXYZ that we want. That's another way to do the question. And let's work it out. So area of WXYZ, that's A, B, C, D, minus 4. And now, what's the area that those triangles? Well, they have a base of 2 and a height of 6. So base times height divided by 2. The 2's will cancel out. And so we'll be left with, well, what's the area of ABCD? 64. Minus 4 times 6, that's 24. So we get 40 once again. Okay, 2 different ways to do it. Pythagoras theorem, that's great. If you spotted that, fantastic. If not, this is just your basic, get a smaller figure by recognizing it as a difference or sums of some other nicer geometric shapes. Square minus 4 triangles. Okay. So that does it for, what question was that? Question number 20. So that wraps up part B. We're going to start into the 5 harder questions, 21, 22, 23, 24, and the dreaded 25. And we'll take a look at those starting in the next video. So I'll see you guys for that.